Hi everyone, thanks for coming to watch our DSEAR overview video. My name is Owen. I'm the Managing Director of OTECSA Consulting, who are a safety consultancy based in Scotland, covering the UK, and we carry out lots of assessments on operations that are covered by the DSEAR regulations. So this is just a short video that will cover some of the main aspects of DSEAR, and it's in advance of an on-demand training course that we're going to develop covering the basics in DSEAR. What is DSEAR? So we often hear about DSEAR related events in industry. They're maybe not termed as that, but here's a recent example. An explosion and fire at an anaerobic digesting facility in Oxfordshire. You can see on the left there's a picture of the pre-explosion site. With the hoods of the digesters shown. They look like inflatables, but they're actually held up by the pressure of the biogas inside the digester being generated. And on the right you can see the aftermath of the explosion. It's understood that there was a lightning strike and there wasn't adequate lightning protection, and this then caused extensive damage. I can imagine that site's going to be down for quite a while. Thankfully, it doesn't sound like there's any injuries from this. They're generally not that heavily manned, these type of sites. But that's an example of a DSEAR-related incident in industry that we might cover with a DSEAR risk assessment. So what is DSEAR? It stands for the Dangerous Substances and Explosive Atmosphere Regulations, 2002. And very simply, it's dealing with anything that could catch fire or explode under normal circumstances in a work environment. So just as a little summary of some examples of DSEAR related materials. Petrol, do we think that's covered by DSEAR? Diesel, alcohol, sugar, and metals. So petrol, absolutely. The flashpoint is around ambient temperature. It's very flammable. So it's definitely covered by DSEAR. Diesel, there was some recent change to the guidance, and diesel came into the DSEAR regulation scope. So anywhere with diesel needs to have a DSEAR risk assessment, even if there's not a specific fire risk from it. Alcohol, most of the time alcohol is covered by DSEAR. If you've got low strength alcohol, beer, wine maybe, not so much, but if you're producing higher strength spirit products, then yes, absolutely, DSEAR is relevant. And sugar and metals, the short answer is yes. Some of these maybe people think are inert, not that hazardous, but in certain forms they can be. So we've got a couple of examples from incidents of these materials. So sugar is a huge dust explosion within a facility in America, in Georgia, which unfortunately killed 14 people, with many more injured. This was generally caused by a lack of housekeeping and management of change, where they changed some processes and changed the way the dust was generated and contained, which found an ignition source and ripped through the facility, causing secondary explosions, as we call them. That's when the dust in an area is dislodged, causing a secondary dust explosion risk. And as you can see from the photo there from the site, a lot of it was destroyed by this event. In the United States, they have some very good investigations carried out and do some great recreation videos for the Chemical Safety Board. So this is one of the ones that's covered by that. There's a very good online video of the Imperial Sugar investigation report. Another example covered by the CSB in America is the Hogan's explosion. This was actually a series of explosions over several months. Generally, again, lots of housekeeping issues, and iron dust is very energetic from an explosion perspective. In one incident, there were unfortunately 2 fatalities when some combustible dust was dislodged by equipment vibration. Again, you can see that's not a photo of the explosion, but it's a recreation from the CSB video. So metal, explosive, yes, in certain forms. Sugar and other organic materials like flour, definitely explosive as well. So DSEAR applies whenever there is work being carried out by an employer and a dangerous substance is present, used or produced in the workplace, which could be at risk to the safety of people as a result of fires, explosions or similar energetic events. So that means that things like high strength acids and alkalis, if they're stored together, if you could get some sort of mixing and energetic events, then DSEAR should really be covering that too. So not just things that can explode or cause fires, but other energetic events. DSEAR is the UK's implementation of the European-wide ATEX directive. In Europe, you don't get DSEAR. It's called the explosion. The relevant document you produce is an explosion protection document. Often in the UK, they're also badged as this, but there's no need for a separate explosion protection document in the UK if a DSEAR report is produced. The DSEAR report should cover all the relevant aspects of the EPD. So here's just a little summary of some of the standards, legislation and guidance that we would use as part of DSEAR. It's just to show you how broad it is. There's industry specific guidance, there's European directives, there's UK implementation of these, and then there's also very useful health and safety guides from the HSE in the UK, many of which are applicable to DSEAR. So how do we do a DSEAR risk assessment? The first step is to carry out the risk assessment part, where we identify what hazardous scenarios could occur. Typically this is with site surveys, or at design stage we may look at talking to the operators and understand how they're going to operate the plant, what could happen, what could go wrong. You would try to understand then what are the consequences, how badly people could be harmed by this, how many people. And then you look at, as with any risk assessment, what currently is in place to prevent that happening, what emergency measures are in place, and what else you could do to prevent the event occurring. So all of that tells us how you could cause a scenario, and the prevention measures and the additional steps you're going to take tells us the basis of safety for the event. Here is the output from a typical DSEAR risk assessment. It covers all the aspects I've just mentioned on the slide before. It looks very much like a HAZAD risk assessment, which is a top-down hazard study. So what we've captured here is some actions for improvement, and after we've done all these steps, we look at risk ranking the scenario. So the risk prior to implementation of actions, and then the risk after actions that we have implemented. As you can see on the bottom, there is a risk matrix which has increasing severity on the left and the frequency of the event on the bottom. So we're looking to reduce the frequency to the acceptable region with the implementation of additional measures. It may be that existing measures are already sufficient to take it to a low risk, but often there are improvements that can be made, and they would need to be looked at in some cases on an ALARP basis, which is when we consider the cost versus the benefit of the improvement. Output from DSEAR risk assessments. Typically there would be recommendations in the areas of all of these categories you can see here. Maybe procedural recommendations, organizational controls that need to be put in place, engineering controls that are recommended, competency or training requirements to be implemented, other relevant recommendations based on good practice in industry, and there may well be the requirement for hazardous area classification. So hazardous area classification is where we need to control ignition sources because of the risk of flammable atmospheres being generated. This could be vapors as a result of liquids being handled, it could be gases, and it could be dust produced from solids handling equipment or dust equipment. So here's a typical example. This is a distilled spirits receiving vessel, relatively small, with a recirculation system. And this is just to show you the output from a hazardous area classification. That is a very in-depth subject. We're not going to get into it, but in our training course we will get a lot more into this topic. So we take our equipment and we carry out the zoning assessment, which then we produce drawings from, so that anyone looking to install equipment or understand how to control ignition sources knows where they need to control ignition sources in that area. You would then select suitable equipment and other ignition source controls to prevent ignition sources in the area, and your hazardous area classification should come with all the relevant information to let you understand how zone sizes were produced, and what the equipment specifications need to be in those zones. Thanks for watching this short video. Please follow all our channels if you can, and give me an email if you've got any questions, and also take a look at our sister design company IDEA, who specialise in multidisciplinary design and consulting services in industrial sectors. Thanks a lot. Bye bye.